welcome to another video. In this video we are going to solve problem number 230, that is kth smallest element in a binary search tree. In this problem they will pass pointer to a root node of a binary search tree and we need to return kth smallest value which is present in that binary search tree. So if you observe this first example, given tree is described in this image and k is 1. That means we have to return the first smallest number which is present in this tree, that is 1. If you observe all the numbers in this array and if you arrange them in increasing order, you will get 1 as the first number. So 1 is the first smallest number, 2 is the second smallest number. So here it is 1 indexed. So here also they have given k as 3. So if you observe all the values which are present in this binary search tree and if you arrange them in increasing order, you will get 1, 2, 3, 4 and 5, 6. So they have given 3. That means we have to return third smallest element. First smallest element is 1, second smallest element is 2 and third smallest element is 3. So the output is 3. So I hope you understood this problem statement, and the writing solution for this problem is very simple, because for a binary search tree, when you do a in-order traversal, it will return array all the values in an increasing order. Once we get these values, we can easily return from that array. So what we are going to do is we are going to do a in-order traversal on this binary search tree. We will get values and we will return that particular index. So let us initialize in order values. Let's this be a list. Initially it will be an empty list, and then we are going to call travel in order function. This thing we have to implement, and we just have to pass the root node of the binary search tree for this function. And finally, since we need to return the k is, they will mention if they mention that k is 1, that means we have to return the first element. In a 0 indexed array, that becomes k minus 1, and then we have to return self dot in order values of k minus 1. So this is the approach. Only thing is we need to implement that in order function. We are going to implement travel in order function as well, which is nothing special, which is exactly equal to in order traversal. So it will get root, and what we are going to do is, if root is null, in that case we will return. Otherwise we will complete traveling the left. We'll go towards the left, root dot left, and then we will process the root node. That means in this case we will append those values to in order values list dot append root dot val, and then we will move towards the right subtree. Travel in order root dot right. And I think this solution works, and this solution is very simple. Only thing is, if we know the properties of binary search tree, when we do a in-order traversal on a binary search tree, we will get all the values in an increasing order, and from that, here we are considering k minus 1 because k, the value mentioned in the problem statement, will be 1 indexed, but in the Python arrays are 0 indexed. Let us run this solution and check whether it passes the initial test cases. Okay, here we are self dot travel in order. Okay, there is a simple typo here. Let us fix it and let us rerun the solution and check whether it passes the initial test cases. Yes, as you can see here, the solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, you can check out other videos from my channel. Thanks for watching this video.